This video is graphing quadratics in standard form. This is standard form. F of x equals ax squared plus bx plus c. Standard form tells you a couple things really quickly. It tells you if a is the coefficient in front of x squared. If a is positive, then the graph opens up like this. If a is negative, the graph opens down like this. Quadratics, or parent graphs, the quadratic parent graph always makes a U shape. Shaped like a U. Alright. The next thing that is easy to spot when a quadratic equation is in standard form is the y-intercept. The y-intercept is always the c value. Because if you remember, in order to find a y-intercept, you set x equal to 0. And if you set x equal to 0, then the a and b would zero out and you'd just be left with c. So the y-intercept, because of that, it's always just the c value. The vertex is the most valuable point that you will identify when you are going to graph a quadratic. It has lots of implications in story problems and in answering questions about minimum or maximum and increasing, decreasing. How you get the x value of the vertex is a little formula, negative b over 2a. This formula comes from the quadratic formula, negative b over 2a. The way you get the y value is you take that x value and you plug it into the original equation and solve for y. So here's an example. F of x equals x squared minus 4x plus 3. I wrote down the values of a, b, and c. A is 1, b is negative 4, and c is 3. So in order to find the vertex, you use this formula. The formula is negative b. So I put the negative 4 in, all over 2a. Then I multiply these two negatives and get positive 4, all over 2. 4 divided by 2 gives me the 2. Next, you take that 2 and plug it in for the x in the equation. 2 squared is 4, minus 4 times 2, which is negative 8, plus 3. You simplify this to 4 minus 8 plus 3, and you get negative 4 plus 3, which is negative 1. Okay, so you have your vertex at 2, negative 1. The axis of symmetry is always the x value of your vertex, but it's a line, so you call it like this, x equals 2. The y-intercept we said was 0, 3. It's because if you put 0 in the equation, the x values cancel out and you just get 3 left over. Okay, the next thing I did was I found some additional points. So I just chose 1, 2, 3, and negative 1. I plugged them in to the equation and I got y values out. Remember, you guys, that f of x is just like y. It's just the function notation. It's the way you talk about functions, f of x. But it's like thinking about it like a y value. Alright, so then I went and put all these points on the graph. I put the vertex at 2, negative 1, the y-intercept at 0, 3. And then my additional points, which were 1, 0, 3, 0, negative 1, 8. And then I found points that were symmetric to them. So I found this orange point, which would be what? 2, 2, 3. And I'm just kidding. It would be 4, 3. So this point is 4, 3. And the other point is 5, 8. But I just did the points by knowing some symmetry, that these parabolas are symmetric. So that's how I found the other 2 orange points right here. I'm going to paint them black now. Great. All right, that's it. That's how you use standard form to graph an equation.